Alright, this is the last video for section 5.4, so nice job in sticking it out with watching all of our videos and having class online. This last slide on page 8 of section 5.4 is going to help you with the last 3 homework questions, and this is about the inverse properties, and that's kind of what I call them. You'll see them labeled a little bit differently in your notes. But one of the properties of inverses is that when you compose the functions, you're always going to get x, and we talked about that in class on Thursday. So what you see here is a composition of a exponential function inside of a logarithm, and notice we get x, and then we have a logarithm as the exponent in an exponential equation, and it simplifies to x. So as we work through these 6 examples, we're going to see that if we use the inverse properties, that it's going to help us simplify things really quickly. For instance, if we recognize this as an inverse property, log base a of a raised to the 8th, then we're going to see right away that this is just equal to 8. Log base a of a kind of cancels out. For instance, I'll show you why. Remember, if we bring 8 down to the front, we have 8 log base a of a, but we know this right here, if we were to write that in a logarithmic expression, right, we know that a raised to the what power is equal to a, so we know that that's just going to be 1, and 1 times 8 is just going to be 8. But you see, instead of using these 2 properties together, we can just use the inverse property, and it kind of cancels out the logarithm. A logarithm that matches its base just kind of cancels out. And we see that here as well because the natural log, remember, is just log base e. So log base e of e raised to the negative t, again, the log base e of e kind of cancels out, and this is just equal to negative t. And similarly, our common logarithm here is log with an implied base 10. So log base 10 of 10 cancels out, and I'm just left with, this is a k, I'm just left with 3k. So we can see by the inverse properties, that's just going to go away and leave us those exponents. So that was kind of using this first logarithm property. Now if we use the exponential property, we're going to see the same thing happen, where the exponential base, when the exponential base matches up with the logarithm base here, it kind of cancels out, and it's just going to equal k. And same thing here, if we look at natural log, which is log base e, log e to the log e cancels out, and I'm just left with 5. Okay, so the e cancels out the natural log. Same thing here, the natural log cancels out the e. And lastly, with the common logarithm, it's an implied base 10, so 10 log 10 cancels out, and I'm just left with 7t. So you're going to see that in 14 through 16 that the answers are going to come pretty quickly, because if you use inverse properties, you're going to see things eliminated right away. Because when you compose functions that are inverses, you're always just left with the x value. Now, over the videos here, we've had a couple different pieces that we've kind of added to the puzzle here with properties of logarithms, the product property, quotient property, power property, and now the inverse properties. So when we come back all together in class and we start solving logarithmic equations, we're going to see all these properties come into play.